Every password you have ever created, every encrypted message you have ever sent, every digital signature protecting your bank account could become completely worthless within the next few years. The security systems defending global infrastructure, military communications, and financial networks are built on mathematical problems that today's computers cannot solve. Quantum computers are being designed specifically to solve those exact problems. And they are getting closer every single day. Right now, a secret race is happening in laboratories across the world. Governments and technology companies are building machines that operate on principles fundamentally different from any computer you have ever used. These quantum computers do not process information as ones and zeros. They exploit the strange behavior of particles at the atomic level, allowing them to test millions of solutions simultaneously. This gives them power that grows exponentially, not linearly. And that power is aimed directly at the encryption protecting modern civilization. Your online security relies on a simple assumption. Certain mathematical problems are so difficult that even the fastest supercomputers would need thousands of years to solve them. Breaking a single RSA encryption key, the standard protecting most internet traffic, would require a conventional computer to factor enormous numbers through trial and error. The numbers are so large that the task becomes effectively impossible. Every secure website, every digital transaction, every protected communication depends on this computational barrier remaining unbreakable. Quantum computers eliminate that barrier entirely. In 1994, mathematician Peter Shor developed an algorithm proving that a sufficiently powerful quantum computer could factor these massive numbers in hours or even minutes. The mathematical foundation of modern encryption would simply collapse. Researchers call this moment Q-Day, the point when quantum computers become powerful enough to break current cryptographic systems. Intelligence agencies and security experts are warning that Q-Day may arrive between 2030 and 2035. Possibly sooner. The threat is not theoretical anymore. In 2019, Google announced its quantum computer achieved quantum supremacy, performing a specific calculation that would take classical supercomputers thousands of years. IBM, Microsoft, and Chinese research institutions have demonstrated similar breakthroughs. These machines are still primitive, containing only dozens or hundreds of quantum bits, called qubits. Breaking modern encryption would require millions of stable qubits. But progress is accelerating faster than most predictions anticipated. What makes this especially dangerous is something called harvest now, decrypt later. Adversaries do not need working quantum computers today to benefit from them tomorrow. Intelligence agencies and criminal organizations are already collecting and storing vast amounts of encrypted data. Medical records, financial information, classified government communications, corporate secrets. They cannot read any of it yet. But they are keeping it, waiting for the moment quantum computers become available. When that happens, everything collected over decades will become instantly readable. Your encrypted messages from today could be exposed in 2032. The implications extend far beyond personal privacy. National security systems, power grid controls, military command networks, and nuclear launch authentication all depend on encryption that quantum computers will compromise. Research published in security journals indicates that adversaries gaining quantum advantage could potentially manipulate financial markets, disable critical infrastructure, or access weapons systems. The entire digital trust framework holding society together is built on mathematical locks that quantum computing will simply pick open. Scientists and cryptographers recognized this threat years ago. The National Institute of Standards and Technology has been working since 2016 to develop post-quantum cryptography, new mathematical approaches designed to resist quantum attacks. In 2024, NIST finalized several quantum-resistant algorithms, and recommended organizations begin transitioning immediately. These new systems are based on different mathematical problems, ones that researchers believe quantum computers cannot solve efficiently. But here is the critical problem. Transitioning global infrastructure to quantum-resistant encryption is an enormous undertaking that will take years, possibly decades. Every device, every network, every system must be updated. Legacy hardware that cannot be updated must be replaced. Software must be rewritten. Standards must be adopted worldwide. Evidence from cybersecurity research suggests most organizations have not even begun this process. Many do not understand the urgency. Others lack the resources or technical capability to make the change. The timeline is compressing dangerously. While some experts believe Q-Day remains a decade away, others warn that classified quantum computing programs may be further advanced than public research indicates. A 2023 report from the Global Risk Institute noted that if adversaries achieve quantum capability even 2 years before defensive systems are ready, the consequences could be catastrophic. There is no way to know for certain where the true cutting edge of quantum development exists. Financial institutions face particular vulnerability. The global banking system processes trillions of dollars in transactions daily, all protected by encryption that quantum computers will break. Blockchain systems, including cryptocurrencies, use cryptographic signatures that would become forgeable. Research indicates that quantum-capable attackers could potentially steal assets, manipulate records, or create counterfeit transactions. The trust mechanisms underlying modern finance could dissolve overnight. This is not a problem that can be solved after quantum computers arrive. By the time Q-Day happens, it will be too late. Organizations must begin transitioning to quantum-resistant security now, even though the immediate threat feels distant. The data you create today, the systems you build today, must be protected against computers that do not fully exist yet. The race between quantum computer development and quantum-resistant security deployment will determine whether the transition happens smoothly or catastrophically. Every month of delay increases the risk. Every system left unprotected becomes a future vulnerability. Governments are issuing urgent guidance. Security agencies are publishing transition timelines. The warnings are clear. Quantum computers will break every security system currently protecting digital civilization. The only question is whether we will be ready when they do. The clock is already running. And for some of your data, it may already be too late.